This video shows the solutions to this week's collaborative problem set. I wanted to make another video for you of this because it's a really important topic and I wanted to make sure you were getting off to a good start. So a company is about to market a new streaming service. It decides to run ads on the Super Bowl. The company hopes the investment in this expensive advertising will result in over 40% of the public recognizing the name of the new streaming service. On the day after the Super Bowl, the advertising company conducts a survey of 420 randomly selected adults and finds that 181 of them recognize the name of the streaming service. What proportion of a sample recognized the streaming service name? Well, the sample proportion, which is symbolized by P with a hat on top, was 181 out of 420 people surveyed, and let's write that as a decimal. So 181 divided by 420 is about 43%. The sample proportion is over 40%. Why can't we conclude the advertising campaign goal was met based on this one sample? Why is your instructor going to have you use some more statistical methods to analyze the data in the rest of this problem? The reason we can't conclude that over 40% of all people have seen this ad is because this was just based on a sample of 420 people. Think of it this way. Here's a picture of the population, and this is all the people that live in this area. And all we've done is we've taken a sample of 420 people and we found a sample proportion of 43%. If you were to survey a different group of 420 people, you'll probably get a different sample proportion. Maybe this one's 38%. Another group, your sample proportion might be 45%. The sample proportions will vary from sample to sample. But what hypothesis testing does is it tells us, does this one sample give us evidence that the population proportion is over 40%. So that's the power of the central limit theorem. The central limit theorem says that if certain conditions are met, n times p and n times 1 minus p, if those conditions are met, that these are both greater than 10, then we can predict the behavior of all of these samples being drawn from the population. And that's what hypothesis testing is based on. So we can't conclude the advertising campaign was met based on the one sample because it's just one sample. Of 420 people. And we want to make a conclusion about the entire population. And whenever we do a hypothesis test or a confidence interval, that conclusion we're writing is about the entire population, not just our little sample, but it's weighing the evidence that the sample gives us about the entire group. Okay, so here we go. Use the sample data to test the hypothesis that the population proportion, again, the proportion of all adults, is greater than 40%. Remember, to do this, you must, and this reviews the 4 steps of hypothesis testing. The first is to write a null and alternative hypothesis. Your null hypothesis is always about the population proportion, and it always has an equal sign in it. And so our null hypothesis is that the population proportion is 40%. And our alternative, we want to see if it's more than 40%, and so that would be a greater than sign. So that's step number 1. Step number 2, we have to show that the conditions for the central limit theorem are met. In other words, n times p. Now n is your sample size, and in this problem, we're told that n was 420. All right, so you have to show that n times p, 420 times 0.40, and n times 1 minus p, 420 times 0.60, you have to show that these are both greater than 10. If either of those is not greater than 10, then we would have to stop. We wouldn't be able to make a conclusion about the population based on this sample because the sample would have been too small. But in this case, these are both greater than 10, which means we can go ahead and continue. Now, what does the central limit theorem say? The central limit theorem says that samples will vary from sample to sample, but we can predict the shape of the sampling distribution. It's going to be normal. It's going to be centered at the hypothesized population proportion. And we could compute something called the standard error, in other words, the spread of this distribution, by using a formula. And then what we're doing is we're trying to see if our sample proportion was 43%, we want to know if 0.43% is unusual. Is it so unusual that it causes us to doubt that the null hypothesis is true? And the way we do that is by computing a test statistic and a p-value. So our test statistic and our p-value are going to be computed using StatCrunch. So we're going to navigate over to StatCrunch, and we're going to get a test statistic and a p-value. So let me just write down the data in this problem, because once I navigate over to StatCrunch, I won't be able to see the problem anymore. All right, so here we go. Okay. So we come here to Stat, Proportion Stats. We have one group, and we have a summary. Okay, so of our survey, 181 people saw the ad out of 420 who were surveyed. We want to do a hypothesis test, and our null hypothesis is that p is equal to 0.40, and our alternative is that p is greater than 0.40. So you don't go to StatCrunch until you've already done step 1 and step 2. And now we'll compute, oops, oh, too many decimal points in my null hypothesis. Let's try that again. Okay, so here's our test statistic, 1.29, and our p-value, which is 0.098. So our p-value is 0.098, and our test statistic, I think, was z is equal to 1.29. So remember, a z-score of 1.29 is not unusual, and your p-value tells you that you could get a sample of 43% about 9.8% of the time, almost 10% of the time, if the curve is centered at 0.40. So this is not an unusual result. So we will not reject the null hypothesis. And so the last thing we do is we write a conclusion in plain English that answers the question. Can we conclude the goal of the ad campaign was met? So there's not enough evidence to conclude. And we're always writing our conclusion about our alternative hypothesis. So you've seen this hopefully in the guided notes that I provided, but it always is about the alternative hypothesis. So there's not enough evidence to conclude, and here you write the alternative hypothesis in plain English. No statistical jargon, something that anyone can understand. So this is our alternative hypothesis. There's not enough evidence to conclude that more than 40% of the population recognize the streaming service name. Use the sample data to construct the 95% confidence interval for the proportion of all adults who recognize the streaming service name. So we'll just come back to StatCrunch. And this time we'll just edit this problem because now, instead of doing a hypothesis test, we'd like to do a confidence interval. So we'll check the confidence interval button. All right, so our lower limit is 38%, or 0.384, and our upper limit is 0.478. All right, so our confidence interval is 0.384 to 0.478. How does your confidence interval support your conclusion of your hypothesis test? Well, think about a number line, and here's 0.40, or in other words, 40%. So our interval goes from 0.384, which would be on this side of 40%, to 0.478, which would be on the other side. An interval that would have supported, how does this support? We concluded that we can't say that more than 40% saw the ad. When you look at this interval, some of it is over 40%, but some of it is under 40%. So it's possible that less than 40% of the population saw the ad. So it supports our conclusion because it includes values that are less than 40%. And that's how our confidence interval supports our hypothesis test conclusion. So this one problem is a good review of Chapter 7 and 8 all the way up to Section 8.4.